Did you know Japanese bullet trains were inspired by a bird named kingfisher? Japanese bullet trains are one of the most efficient and fastest trains on the earth, with 300 km/h speed, and they are never late. Due to the lesser friction with the air, these trains are able to use 15% less electricity and 10% faster than before. This is an example of biomimicry. As human population increases, the need for clean water also increases. Wastewater derived from household, industrial, agriculture, and hospital often contains chemical and biological waste that can be harmful to human and other organisms. Yet, current wastewater treatment systems such as activated sludge, tricking filter, and membrane bioreactors are inefficient enough to remove all toxins and heavy metals from the wastewater. Therefore, this concept was aimed to offer a new option to wastewater treatment by utilizing nanotechnology. However, a scaffold is required to recycle the nanoparticles in wastewater treatment, since the usage of nanoparticles in powder form are impractical and non-reusable. Therefore, 3D printing technology was adopted to print a scaffold with high surface area to maximize the exposure of nanoparticles towards the pollutants. In this project related to biomimicry, our 3D structure was inspired by the honeycomb structures made by bees. Due to its hexagonal shape, it provides immense part strength to a prototype. It was proven in 1998 by a mathematician named Thomas C.H that the honeycomb pattern uses the least possible material, and that is why both 3D printers and bees use it. By redistributing the force to all parts of the structure, honeycomb is better able to handle general mechanical forces than any other pattern. Even the eyes of insects are arranged in hexagonal shape for maximum light sensing area. In the construction of buildings such as Dual Tower in Singapore and Home in US, honeycomb shape was used. Home building was designed to provide solutions to thousands of homeless people in the city, since rental rates are high in New York City. Since there is more usable space inside the hexagonal building compared to rectangular building, fewer materials are needed to construct the walls and floors. This results in lower cost. In relation to biomimicry, our 3D structure was inspired by the honeycomb structure. It was then designed using a software known as Mesh Mixer and printed using a 3D printer. Lastly, it will be tested on the degradation of dye and antimicrobial performance. As shown in the diagram, 3D honeycomb structure was able to inhibit the bacteria after 18 minutes, whereas bacterial growth are still present after 2 hours in the absence of 3D honeycomb structure. According to the graph, a strong antibacterial effect of the 3D honeycomb structure was observed at 40 minutes of exposure under UV light and completely inhibited at 100 minutes. On the other hand, photocatalytic result shows that the color change of methylene blue dye was lighter after 3 hours of exposure under UV light. As shown in the graph, the concentration of dye dropped from 9 mg per liter to 4 mg per liter. It can be concluded that 56% of methylene blue dye was degraded. Lastly, the stirring effect of spherical and cubic structure was compared. It was observed that spherical structure remained as it is after vigorous stirring, while cubic structure had broken pieces after the stirring. This is due to the nature of the sphere shape follows the flow of water, making it a mechanically strong shape that is suitable for stirring. Inhibition of bacteria and degradation of dye is possible due to the titanium dioxide nanoparticles present in the 3D honeycomb structure. Upon exposure to UV light, electrons from valence band move to the conduction band, leaving holes on the surface of titanium dioxide nanoparticles. Electrons then react with water and oxygen from the air to produce reactive oxygen species, which oxidizes the cell wall of bacteria and dye into non-harmful compound. Biomimicry solves mankind problems. In the application of wastewater treatment, the biomimicry of honeycomb structure provides a mechanically strong scaffold with high surface area. As demonstrated, this structure was proven to be able to degrade dye and inhibit bacteria under UV light. The proposed idea has the commercial potential for the manufacturers using dye in the production or discharge of organic waste, waste management providers, and agriculture industry. Nature definitely has its way of finding simple rules to elegant solutions. So the next time when you see something new, think of why and how. Be curious and love science. Thank you.